Alright, so here we have derivation of analytical formula to find vector addition of two vectors using parallelogram law. So already we know that if these are two vectors A and B, so their resultant R will be given by the diagonal corresponding to which is originating from the same point that the vectors are originating, and R is equal to A square plus B square plus 2AB cos theta, where theta is angle between the two vectors. But today I'm going to derive this expression, and I'm using parallelogram law for its derivation, and later on I will tell you that by triangle law how can you find it of your own. I'm telling you by parallelogram law. Okay, so first let me draw a diagram. Let us suppose these are two vectors. Uh, right now I am writing their magnitudes only because I am taking this situation completely geometrically. So for me, A is just a number, just a length, let us suppose, and that is why I am not putting vector sign over here. And this is B. Okay, and angle between them is theta. Actually, what we obtain from this formula is the magnitude of vector addition. So that is why I'm just interested in its magnitude, its numeric value, its mod. So first, according to parallelogram, if A and B are two vectors acting along the adjacent sides of a parallelogram, then the corresponding diagonal originating from the same initial point, that of two vectors, will represent their vector addition. Means this diagonal, there is this diagonal also, but this diagonal which is originating from the same point, that of two vectors, so this will be their resultant. You can ask me why I'm putting arrows here, because it shows vector addition, but we are dealing with mod magnitude only, so I have put mod here, modulus over it. But it means that it is not just A plus B, just the addition of A and B. It is the vector addition, and then we are taking magnitude of it, and then we are finding this. All right, so angle between them is theta. If I produce this side further, then this angle will also be theta. And if I draw perpendicular over it, so I can name this all the vertex here. I'm using W, X, Y, and Z, because I can't take PQR, there it is R. I can't take ABC because AB are already there. You can choose any of the alphabet. If this is B, this is also B. And by trigonometry, we can say that this is B sine theta, and this is B cos theta by trigonometry. And what else? Now see, if I take only this part, so this is a right angled triangle, and we can directly apply Pythagoras theorem here. So, as I told you, the nature of vectors is associated with geometry, and we can solve them by geometrical all the geometrical process and according to all geometrical laws. So here, and trigonometry also. Yeah. Okay, now see, if we want to find this resultant r, then we'll use Pythagoras theorem. So Wx is equal to root of xy square plus wy square. Mm, I should derive it there. Yeah. Now it has perfect balance. And what is this b doing here? Okay. So this xy square means b square sine square theta plus wy square means a plus b cos theta square, and from here it will be b square sine square theta plus a square plus b square cos square theta plus 2ab cos theta. If we take b square sine square b square common from both of them, so that will be a square plus b square sine square theta plus cos square theta plus 2ab cos theta. So the resultant will be, this is what the formula was. But as we are dealing with a vector quantity, still r will be the resultant and it will also be a vector. So that vector should be uh, expressed in terms of some location, some direction. So how can we give the direction of this resultant? So right now we can just express its direction in terms of a or b only. We don't have any other information for this. Maybe in some numerical they will give you some information about coordinates. There will be a is along x axis or something like that. There it is easier to tell the direction of this resultant. But here we can just give the direction of r in reference with a or b. So let us suppose this resultant is making an angle alpha, and now don't get confused because already we have this angle theta, but it is the angle between a and b. This alpha is the angle made by r with a. So just in order to uh, express the direction of r, so tan alpha, where alpha is angle between r and a, so tan alpha is equal to this perpendicular means b sine theta upon this base a plus b cos theta. See, we can't find alpha directly, so we take use of trigonometry. Then alpha equal to tan inverse. This is the way to express angles. If we know the value of particular trigonometric ratio, then we can directly write. If we don't, we express it like this. Similarly, we can do it with B also. I'm leaving it for you. I will tell you the how it would look like, but you have to do it yourself. So I have produced this and drawn a perpendicular. So we have to take this triangle, and there is beta. You can choose any angle, you can give any name instead of alpha beta, you can give phi psi or any other. Okay, so if that is beta, then mm, beta is equal to tan inverse a sine theta divided by b plus a cos theta. So this is how we can derive, and as I told you that same derivation you can do using triangle law, because ultimately you can see if we follow triangle law, then you can see in triangle law what happens. In triangle law we have two vectors A and B, and this is the third side taken in opposite order is their resultant. All right, this is the angle theta between them, and it looks the same as I have just highlighted with red color. This is B sine theta, this is B cos theta. You can see ultimately the basic structure is same. So if it is asked in to find to derive this result using triangle law, you can still do it. So I'm leaving this exercise up to you, and uh, in next we are going to study about vector subtraction.